Welcome to lesson 9.4 on Arithmetic Series. What's Arithmetic Series, you might ask? Well, a series is basically a sequence, only you're adding terms up. So that's the only difference between a sequence and a series. Arithmetic sequence, 1, 2, 3, 4. Series, 1 plus 2 plus 3 plus 4. We can find the sum of an arithmetic series provided it's finite, meaning it ends. It doesn't go on forever and ever and ever. So here's an example of an arithmetic series. 2 plus 7 plus 12 plus 17 all the way up to 82. We can find the sum of an arithmetic series using this formula right here. Another one of our formulas to add to our list of formulas that we need to know. And this one here, I've got what n is. N is just however many terms you have. A1, of course, is the first term, and a sub n is going to be the nth term or the last term you're going to. So the tricky part on some of these is figuring out what's that last term we're going to. And that would be, in my example up here, very tricky to figure out because, well, we got 82. I don't know how far along the line is. I know this is the first term. I know this is the second. This is the third, fourth. I don't know what this is. Now, it's pretty easy to figure out. Here's how you can figure that out. We'll use this on our first example down there. So once we get to the first example, maybe you want to pause and give it a shot. But if you do this, follow the pattern, follow the formula. You'd say n is however many terms. I don't know that. I do know A1 is 2, and I don't know the last term. But I can figure it out. How do I figure it out? I use the rule. The arithmetic rule, the one I gave you, is a sub n equals a sub 0 plus dn. This one pattern goes up by 5s. That's my d. And a0 would be the term to the left of the second term, which would be 5 left, or at -3. I can use that now to figure out where 82 is in the mix. Because I want to know where 82 is so I can plug it in for n. So I want to be able to solve for n. To solve for n, I simply say I want the 82nd term. I want to know where that is. So add 3, divide by 5, and I find out that it is the, how many times is 5 going 85? Looks like 17 times. So n is 17, and 82 is the 17th term. So I didn't know 82 up here. I should have said that. This I did know. Sorry, 82. I knew what the last term was. What I didn't know is what spot it was in. So there are 17 numbers here. All I need to do is do 2 plus 82, which is 84, and multiply that by 17 halves, which is 8.5. So put 84 times 8.5 in your calculator. And you get 714. That's the sum of this arithmetic sequence up there. Or series, I should say. The reason it works, let's take a little bit closer look at 2 plus 7 plus 12 plus 17 plus 82 is this. Let's write 2 plus 7 plus 12, and then let's go towards the end here. What would be to the left of 82? Well, there would be a 77 and a 72. It would look like this at the end. Why is that significant? Well, what's happening here is I'm basically taking 2 plus 82 to get 84. My 84, and I also then can take a second term and add it to the second to last term, and look, that's still 84. And every time I do that, I take the third term times plus the third to the last term, add those up, I get 84. So you're going to keep getting 84s. That's why we add the first to the last. We're trying to figure out what's that common sum that you're going to get, and here would be 84. And then the question is, how many 84s do you get? Well, since there's 17 numbers, that's 8.5 pairs. That's why we do 17 divided by 2, you get 8.5 pairs. So you'd have 8 pairs, plus there would be that extra number in the middle. That extra number would be 42. So that's the reason why this works. That's the reasoning behind the formula. So again, first example, maybe you want to try, pause, see how you do. Otherwise, I'll run through it now. I want to find the sum. I need the number of terms, which I don't know. 5 by 2. I need to add the first and the last term. So I have something over 2 times 42. What's that something? Well, I come up with the arithmetic formula and say I want to know where's 32. What position is 32 in? I know A0. A0 would be 2 to the left of 10. That's 8. I know D, it goes up by 2s. That's my pattern. Up by 2, up by 2, and I want to find N. That's what will tell me what position the 32 is in. Subtract over the A, divide by 2, and we find out that it is the 12th number. So I've got 12 divided by 2 over times 42. So I have 6 times 42. 6 times 40 is 240. 6 times 2 is 12. Add those together. You get an overall sum of 252. So that's how the sum formula for an arithmetic series works. We're going to continue to use that formula, but we're going to apply it to something that looks a little bit different, and this is called summation notation. This right here is called summation notation. What this means over here is we're going to take a 1 and we're going to plug it in, and that will get us -2. And this means we're going to take 1 and plug in all the way up to 60. So I would plug in 2, I'd get 1, I'd plug in 3, I'd get 4, I'd plug in 4, I'd get 7, and we're going to keep doing this, until we plug in 60, where I get 180 minus 5, it's 175. Okay. This is sigma, it's a Greek letter, and all that's telling us to do is to add these up. So this is another way to write -2 plus 1 plus 4 plus 7 plus ... plus my last term was 175. Okay, so sigma notation is just a fancy way to write an arithmetic, well in this case an arithmetic series. It doesn't have to be arithmetic, it could be any pattern for that matter, but not for our purposes, we're working with arithmetic today. So, since it's arithmetic, and I could have noticed it's arithmetic, I would rather you guys notice the arithmetic right away by saying, oh, I know this is arithmetic because arithmetic are linear. Arithmetic patterns are linear. And 3i minus 5 is certainly linear. It has a slope of 3 and a y-intercept of -5. Well, we just need to plug in into our summation, or our sum formula from above. What's n? N is the number of terms, and that was actually given to us on that one. This is 60. A1, that would be the first term, that would be -2. And then A sub n is the 60th term, the last term, which is 175. So this is what I need to do to evaluate this sum. I need to say there's not just 60 numbers, there's 30 pairs. And those 30 pairs add up to 173. So I take 30, multiply by 173. Now 3 times 17 is 51. 3 times 3 is 9, so that would be 51 with a 9 after it. And then it was actually 30, so it should be 5190. So we got 30 times 173, better be 5190. That's your overall sum. And again, you have 30 pairs that add up to 173. Negative 2 and 175 is 173. What term would there be before 175? It'd be 3 less, 172. And when you add these up, you get 173. And what would be before 172? 169. And when you add 4 to that, you get 173. So you're going to get a whole bunch of 173s. Okay, example 3, same thing. You might want to pause me here and give it a shot. Okay. What we have here, again, is linear. This is linear. It's got a y equals mx plus b. Look, it's got a slope of negative 1.5. It's got a y-intercept of 12. I'm just going to go straight to the pattern on this one. N is the number of terms. That's my top number in this case because it starts at 1. We got n equals 1. It goes from 1 up to 120. Sorry for the size of this, but it's a 1 on the bottom. It's 120 on the top. So there are 120 terms. That means there's 60 pairs. The first term is what you get when you plug in a 1. Oops, excuse me there. Let's try that again. 12 minus 1.5 times 1. So 12 minus 1.5 is 10.5. That's the first term. And the nth term is what you get when you plug in the last number, which in this case is 120. That's my n. That's my last number. That's what we want to go up to. So that one would be 12 minus 1.5 times 120. 12 minus a half of 120 is 60. Add that to 120, and I got 180. That's 1.5 of 120. 12 minus 180 is negative 168. Okay. So what did 10.5 and negative 168 add up to? That'd be negative 157.5. 168 minus 10 is 158. Minus a half more is 157.5. It was the other direction as far as the plus minus goes, so it's negative, not positive. Now I'm going to put calculator 60 times negative 157.5. Get negative 9,450. Okay, we're going to wrap it up here. We've got 2 left. 4 and 5 are a little bit different because they're not arithmetic. Okay? So they're not arithmetic because, see, I got 2n squared minus 1. That's actually quadratic. I want it to be linear. They're not arithmetic. So if you have a problem like this, all you can do, well, there's a couple things, but all you're going to know how to do today is say, I need to go from 1 to 5 and plug them in. So I'm plugging in 1, I'm plugging in 2, I'm plugging in 3, plugging in 4, and finally plugging in 5. And I'm going to evaluate all of those. So 1 to 5, this is a 1, there's a 5 up here. It tells me there's 5 terms, 1 to 5. Plug those in and evaluate. So then here I have 2 minus 1 is 1. Here I'd have 2 times 4 is 8, minus 1 is 7. Here I'd have 2 times 9 is 18, minus 1 is 17. Here I'd have 2 times 16 is 32, minus 1 is 31. And here I'd have 2 times 25 is 50, minus 1 is 49. And because it's got that sigma up there, that's telling me what I need to do is add these up. So we're going to go ahead and add those numbers up. I'm actually going to work from right to left on this. This will give me 80, 97, 104, 105. So we can't use the sum formula for arithmetic if it's not arithmetic. And make sure you're aware. It might deal with arithmetic or not. This is not. So we're just going to go ahead and plug them in. Add them up. Example 5. Is that arithmetic? It's got a cube in it. That's cubic. That's not arithmetic. So since it's not arithmetic, we're going to plug them in and add them up. Now, what do we plug in? Maybe you want to give it a shot. Pause this and come back and check. Otherwise, what do we plug in? 3 through 6. This one starts at a 3. So I'm going to plug in 3 first. So I'm going to go 3 cubed minus 5. Then I'm going to go 4 cubed minus 5. Then I'm going to go 5 cubed minus 5. And finally I'm going to go 6 cubed minus 5. Plugged in 3 through 6. Evaluate each of those. I'd have 27 minus 5 is 22. 64 minus 5 is 59. 125 minus 5 is 120. And 216 minus 5 is 211. And I need to add up those 4 numbers right there to get my overall answer. So this one I'm going to jump around a little bit, and I see that I can put 211 with 59 pretty easily. That would get me 270. And I'm going to add that to the 120. That'll get me up to 390. And then finally I'm going to add the 22 on there and get 412. So what have we done? We've worked on arithmetic series formula, how to come up with a sum of some kind of arithmetic series. And then we followed up with, let's just look at that sigma notation. What if it's not arithmetic? Well, then we're plugging in and adding them up. So that's the gist of section 9.4. Thanks for watching. Have a great day.